Welcome to the orientation to the new Masters of Science program in Science, Translation, and Outreach, abbreviated STO, so I'll commonly refer to it as the STO program. My name is Paul Vincelli. I am the Director of Graduate Studies for this new program, and I'm very excited about the program as you'll come to see as we go through this orientation. But this orientation is meant to give incoming students some important information that will help you prepare in the coming weeks and months for the study in the program. So this is really important to give you this orientation, so I hope you'll follow through the 4 parts that we've created. Okay, and I'm also giving you contact information there as well. Please feel free as students in the STO program to contact me anytime with any questions or concerns. So this is a 4-part orientation online and recorded. And so these are the 4 parts that we'll be going through, and they're independent, so you can stop after each one and pick up the next one. First is the philosophy and need for the program. Secondly is the program of study, kind of a description of what is involved in this program. Third is your advisory committee, and the word your is chosen very carefully. This is your advisory committee. And finally, a wrap-up where we cover some additional topics. So let's get started with part 1, philosophy and need for the program. So one of the things surveys show over and over, that Americans are actually very respectful of the place of science in our world today, and the place of science in being able to make for better lives. Americans do appreciate scientists by and large, and we scientists are very happy about that. And so this is all to the good as far as science is concerned, but there are challenges in integrating scientific information that's out there in the scientific literature into forms that people can use in creating healthier, more productive local systems. And there are basically 2 major types of challenges. One is locating and evaluating information that is presented as scientific, and we'll talk about that. And the second is using credible information. Once you've identified that information, how do you use it to inform policies and programs that can make for better lives and for a healthier environment? So these are the 2 major types, and we'll spend some time on each of these, but we'll start with locating and evaluating information presented as scientific. So locating is the easy part. It's easy to find scientific information on the internet, for example. The hard part is being able to evaluate that information and decide if that information really represents the scientific community, whether it represents valid science or even misrepresentation. And this is a big reason for the STO program. So the internet is like a hall of mirrors, I once read, and I love that description because yeah, you can sort of see which is the real image in this picture. It's the guy on the left. But there's all these sort of phantom images that could mislead you into thinking that they were him. And that's the way it is with scientific information on the internet. You can find lots of it, but really, which is the information that you can place your trust in order to create programs that people can use? And so this is an ongoing process. You'll never be done learning how to identify and follow scientific information that's useful, but this image kind of gives us a sense of that. So let's look at some data here. We're going to begin our graduate studies by being data-oriented, as we should be. And so these are representative opinions of the general public, the black dots on the left end of the blue bar, and the white dots are representative of American Association for the Advancement of Science scientists. So members of the American Association for the Advancement of Scientists are represented by these white bars to the right, rather these white circles. And so let's take an example of what is this chart actually showing us. Okay, so let's take the bottom one. The statement is childhood vaccines such as MMR should be required. Okay, now you can agree yes or no. And so when they surveyed members of the American Association for the Advancement of Scientists, of science who are basically scientists, right? These are professional scientists largely. They may not be an expert, most of them are not experts in vaccines, but they're generally aware of scientific knowledge across the board. And you find that 86% of AAAS members believe that these vaccines are useful, safe, and should be required. Whereas the general public is somewhere around 68%. So there's a little bit of doubt there compared to what scientists think, but that's an 18% difference, and that's significant. But that's that's just the fact of life. So let's take another look. Here's the statement: is safe to eat foods grown with pesticides. So here we find a really big difference between what scientists generally think on the right, 68%, versus, and again, these are not experts in pesticides per se, but they're just not generally knowledgeable about the world of science because they're scientific members of the American Association for the Advancement of Science. And so 68% think foods treated with pesticides are safe to eat, whereas only 28% of the public thinks this. So that's a big difference between what scientists think and what the public thinks. And the scientists could be wrong, but generally I'm going to go with the scientists because these are populations of very well-educated people in the world of science. So that's a big difference. And then this one here is even a bigger difference. In fact, it's the biggest difference documented in this study. AAAS scientist members generally think these are safe foods to eat, 88%. And if you talk to experts in molecular biology, that number goes even higher. So remember that white dot represents scientists across the board. This may be geologists or social scientists or people with no background in food production. And so that, that 88% probably represents some people that may not know very much about genetic engineering. But if you ask actually experts in genetic engineering, you'll find it's even higher than the 88% represented. But okay, we'll go with 88%. And then US adults, only 37% think that these are safe foods. So again, that just shows the kind of difference that can be between where scientists are on an issue and where the general public is. And I think I've got one more. This is an important one. So this is, on the right is our AAAS members. 87% think that climate change is largely due to human activity, whereas only 50% of the American public at the time of this sampling thought that this was due to human activity. So that's a really important one, and these are some of the things you might get involved with in science translation and outreach. One of the questions for you is, are any of these topics political? Well, you might think so, and people often do. They think climate change is political. The science of that statement, climate change is mostly due to human activity, is actually not a political statement. There may be political aspects of what we do about climate change, and we might have political debates about what we do. But the fact of that statement of fact, climate change is mostly due to human activity, is actually not at all a political statement. It's a statement of fact from the scientific world. So anyway, and then do any of these trigger emotions in you? Right? Do any of these statements make you angry in some way or worried or whatever? If any of them do trigger emotion, that's often a good indicator that it's a topic that might be important to study. So you can dig past your own emotional reactions and get to the core of what the science says. And now we're talking about evidence-based science. Knowledge gaps. The difference between what we know and what we know as individuals and what is known by people, okay, by humans. The knowledge gap, difference between what we know and what is known by humans. And we all have knowledge gaps. It's something we have to recognize that we all have them. Everybody does, professors certainly, very much so. But it's important to think, are we aware of our own knowledge gaps? Do we know when we have a knowledge gap and how big that knowledge gap might be in a particular area that's important to us? And also, how do we keep an open mind about our knowledge gaps? How do we keep this sort of sense of, okay, I think I know something, but I might not really understand it. So I'm willing to dig further and see and test my knowledge and see whether it represents what is known by experts in the world of science versus what I've read maybe on the internet, which may not actually be our current understanding. Here's another topic. You're going to get into this as we go through the course, but confirmation bias. It is what it says, and that is confirmation bias is basically when I want to confirm some, quote, fact. Okay, when I want to confirm something that I think is fact, instead of really evaluating whether it is a fact and a well-supported fact or not. So the internet has actually made it easy to exercise confirmation bias. You can find sources of, quote, scientific information on any topic you want that are wrong, and they may even be purposefully misrepresenting that information. So the internet has not really created the age of information. I like to think of it as creating an age of misinformation. And so this is why science translation and outreach becomes more and more important every passing day. And the second point about confirmation bias is how do we reduce our natural human tendency towards confirmation bias. And you're going to learn something about that in this program. It's a hard thing to do, but it can be exercised, that ability to dig past your own confirmation bias. So another way of phrasing this is how do we distinguish institutions and sources that are well grounded in science versus the sort of do-it-your-own expertise. And what I mean by do-it-your-own expertise is I'm smart, I got a computer, I'm going to go on the internet and find the answer. And a few hours of doing that, or even a few days, and it's tempting to think, well, I know what I'm talking about. And maybe one doesn't, especially if one goes in with a sort of a confirmation bias. So again, these are things that that explain why we think the STO program is so important, and this is really a key rationale for the program. Now I showed some controversial topics in that survey data that we looked at. The STO program is really not about controversial science per se, but we do wade into controversial topics. But most of all, it's about applying credible scientific findings for good ends to solve problems that people have in their world. And so sometimes that involves getting into controversial issues, but just as often it doesn't. It's really about finding good quality scientific information and applying it to good ends. So we talked at length about locating and evaluating information presented as, quote, scientific. Let's say a little bit about the second major type of challenge, and that is using credible scientific information to inform policies and programs. And we'll just say a few things about this. And so really the question is, how do we translate scientific information into programs that improve local systems? How do we do that? And the STO core courses will help you understand how to go about that process of turning good scientific information into programs. So the concept of a knowledge deficit is we've already seen that when we looked at the survey data, and knowledge deficits, again, are knowledge gaps we all have. So imagine that we're trying to fill a hole, with soil, right, in a wheelbarrow, okay? That's the concept of filling a knowledge gap or a knowledge deficit. And filling a knowledge gap in the public is not going to change policy by itself, okay? Because often there are values issues that people are that are embedded into issues that affect local systems. So just filling knowledge gaps is not enough to creating useful programming. But filling knowledge gaps is a necessary component of addressing or of translating science into usable programs. So it's a necessary component to fill knowledge gaps, but don't think that it's all you need to do, because you do need programs that reach out to people and connect to them on their own level of values and concerns. Finally, I think this is important to understand that this master's program, like any master's program, has a rooting in scholarship. And the name that we would give this form of scholarship that you're primarily going to be practicing in this program is the scholarship of engagement. And what that means is that you are taking credible disciplinary science, that is from disciplines of scientific study, of which there are hundreds, and you may be digging into a small number of those in your coursework or your capstone project, but you dig into those and you then turn that into something practical for the public. Okay, on some level, you're taking that disciplinary knowledge and putting it into the hands of the public in a useful way. That's engagement. And so doing this in a scholastic way is what we refer to as the scholarship of engagement. So that's what you're going to be doing. If you're interested in the scholarship of engagement, I've given you some citations, and you can always contact me and we can talk more about it.